Hello, good morning. Right now, already room time. We'll get started. We come to the chapter 10, the interpreter design for the read, evaluate, print loop, repeat loop chapter. And then we will be on the virtual machine. We'll be on the virtual machine. So this virtual machine is very important. So basically, we go over the compiler or interpreter design from chapter 11 to now. And then basically, we talk about a scanner, and then we talk about a parser. And then these two in combine will become a compiler or a interpreter. So this one will be talking about the integration of interpreter. And then we'll also talk about the back end of the compiler, that is the code generation and the execution part. So a Python language has a virtual machine. So you will compile your Python language to intermediate code and then run on the virtual machine. So that's why here we have the virtual machine. So if you are the C language, it will be compiled to machine code and then intermediate code and then backend optimization to the machine code. So then they will have no virtual machine and you will be running on the regular CPU. So now basically this one is to talk about the backend model of the machine and also talk about how interpreter work to work with the virtual machine. So here, repeat loop means the interpreter that actually take one line of the code to the compiler, to the interpreter, to the scanner, and then to the parser, and then convert it to the code that can be run on the virtual machine. So Liquid is the user interface of the interpreter. And then we will talk about the virtual machine model and then how this virtual machine would work. And then the whole thing will be integrated as a interpreter. So first, we need to know about what is virtual machine, and Python is an interpreted language. So we interpreted the one line after a line, and then find the executable code. But here we do not convert it to the machine executable code, but we convert it to some sort of intermediate code for Python. So it actually called PYC, Python compile code, called PYC code, the intermediate code. And then those compile code is actually in the virtual machine language, and the virtual machine language can be run on the interpreter at a real time on the interpreter. So it's different from the C++. Okay. So basically, your source code compiled to bytecode. Bytecode is the PYC code. And then you run on your virtual machine with the library. So is Python a interpreted language? Yeah, it says interpreted language. And then it would during the interpretation, they also have a concrete syntax tree or parsing tree will be created in the virtual machine, and it will be compiled to the Python bytecode. So it's called .pyc file. So right here, let's assume that we have a function called a comma b, okay, a function of the a function. And then if you actually print a that underline code underline that co underline code, you will get a bytecode like this. You will print out like this. This is a binary string. And then like this, okay. And it is a slash x00 is a byte of 0, then byte of 1, byte of the hexadecimal 17, okay, something like that. So you will print out as the ASCII code or this much, okay? And that is your code. So if you actually import this is the this interpreter, okay? It actually is the it actually will disassembly your code. So this that operator, this is an array, okay? So you actually import this and then actually running on the edge. Then it will show you this kind of disassembly the code. It will generate this low fast binary add and then return value. So this one is you load one value to register A, load one value to register B, and then sum them up by add, and then the result will be returned. So this is the bytecode of your function. And this one can be shown using the this function. So ADD is a module, and that module will be disassembled. Okay. Okay, so there is a load fast. It's loading the value to the register in a fast mode. So it actually is optimize the loading. Okay. Anyway, so here if you print at 57, you will get the result. So after compilation, this is the code. And then if you look at the dictionary, okay, for easier process, your executable would be like this, your instruction and the numbers. Numbers are the two numbers that will be loaded to the registers. So this one is the executable for your at the 57. Okay, so let's actually look at if you have the executable code of this, and then you actually create a AZPY interpreter. So you can, this interpreter already an interpreter, and then you load your executable code to your interpreter and run it. This is the function of interpreter. So this interpreter is similar to the interpreter that we got, have the parser and scanner. But this parser and scanner result will be this executable code. So this interpreter is the backend virtual machine. It's the backend virtual machine, but it's a easy version. It's an easy version. So when you run it, you get some result anyway. So here talk about a code stack. Okay, this one I think is okay. You can actually look at it, code stack of the interpreter. So your source code, here, let's actually look at this one called CPython, CPython interpreter. Your source code will be compiled by CPython compiler, and you generate the CPython bytecode, and then you run on a virtual machine. So this is a CPython interpreter. And it is faster because it's a C version. You would write in a Python language, but run like a running C code. So it's C Python interpreter. So you can look at this document. There might be newer version, but you can look at this one. So Python is a dynamic Python language. The runtime will determine the type. Okay. So here, let's assume we have a function of mod A comma B. You have the mod function using the percentage sign. But the percentage sign will have several meanings. If it is a percentage sign, it is for the arithmetic, it will be what the percentage sign actually is work as the taking a modular. But if it is for the string, the percentage sign will be using the parameter couple to the pattern. Okay. So here we actually print out the disassembly code. So Byron is a Python interpreter implemented in Python. So Byron is a version, it actually can be found on the internet. Okay, so it actually is an interpreter. So here we actually introduce the AG, the simple version of AD interpreter. This is a simple version. Okay, very, very simple version. It comes with the stack, come with the print value, come with the binary add function. So give you a very simple version of interpreter in the Python format. And Byron is a little bit more complicated version. So you can consider it's a version 2 Byron, okay? A little bit more difficult than the AG Python interpreter. So this one built by this gentleman. So here talk about how to build an interpreter. So a tiny interpreter with the virtual machine of 3 instructions. And then you have the code, and then you can feed in those code to the stack machine to run. Okay, so this is a interpreter. Here we use a very simple version of the Python, just let you know what is the design of the interpreter. Okay, so basically you got a dictionary of instructions, and then basically you feed into the run code of the interpreter. Okay, anyway. So now then your interpreter may become a little bit more complicated with the store, load, print, more functions. So this is interpreter 2. We give you an interpreter 2 example. It can be a function of S function A equal 1, B equals 2, and print AB. Okay, this is the interpreter. And then we go into the version 3 that actually is a little bit more detailed version that actually is called real Python run code. That actually is in real Python's byte code. So you have a conditional statement in this one, and then you will generate the bytecode according to the disassembly result. And then this is the assembly code or virtual machine code. And then you can look at the data structure and the code itself. Okay, anyway, this one can also be run on your Python interpreter, real Python interpreter. So the next one is talking about even more virtual version 4 Python interpreter that comes with the code stack. We call it frame. So talking about how frame being handled when you have multiple function code, bar and full, and then how the code stack work. So then Byron version. Okay, and then you talk about how to define a virtual machine. So this virtual machine is also an interpreter. And then it comes with init and also run code module. And the code stack part can separate it as a frame class. Okay, anyway, it will have the run frame, pop frame, push frame. And then function is another class. So this whole thing, class, virtual machine, function, and frames, they would be integrated together as a virtual machine. Anyway, there's a job dispatch module, block module. Okay, so that is the Byron version. And then next one is like the real version of the Python for the full implementation. Okay, anyway, more operators. Then talk about dynamic typing part of the compiler. Okay, anyway. This one you have to look at the code and then look at how this Byron run. But this one give you the idea of how a virtual machine being constructed from simple version to more complicated version. Go version by version, and then it is used to replace the SciPython. But you can actually download the SciPython, the C Python version, and then run it. So on the internet, there's also another version called XPython. That's also a dialect of the C Python, but it actually give you the bytecode better. So we actually recommend you to study this version called XPython. You can download it from the internet. Okay, this is how to install it. Use pip install XPython. And then you have a demo program that is, and you run XPython -v. -v is compiled to virtual machine code. And then the virtual machine code will show you the disassembly result of that. This is called XPython. So here GCD function, and then it's related machine code, virtual machine code. Okay, that's it. So this whole chapter teach you how to disassembly a Python code, and then also talk about what is the virtual machine code, and give you the idea of how the backend interpreter should work. And this virtual machine can be used. The concept is similar for Python and also for the just-in-time compiler for the interpreter for the Java language. Java language backend is also a virtual machine. And for C double plus compiler, that would be different. They will be compiled to the real machine code. That would be different. But right here, we do show you the whole backend of a Python interpreter. So again, today we are on a Monday and we are a question and answer session. But so far, I do not see anyone coming in. So I'm going to go offline. So let me know if you have other questions. Just let me know. Okay, thank you. Bye now.